today, exponential growth and decay. Exponential growth and decay.
Talking about 7 feet under here.
It's a dark thing to say. Okay, so I want you to imagine that Brock, from Brock, he's not here, but he's building an addition to his home, and he needs to hire a contractor to do it. Okay, moving on. So Alondra quotes him a price. Alondra's going to do it for $150,000, and it's going to take her 25 days. 25 days. She's good. She's got a team. She's got a team of top people, crack people. Alondra mostly like sips her cup of coffee and says like, "You work harder." She's very good. She's very good. Okay, so this is Alondra's offer. She says, "Listen, I'm good, and I'm kind of desperate for work. You know, I've been recording these lessons and saying some pretty weird stuff, and it's only a matter of time. So I think I got to think about the future. This teaching thing obviously isn't going to last." So I undercut her and I say, "You know what? I'm going to do it for a penny." So Brock takes me, and I'm going to do it in 24 days, but not just a penny every day. Well, okay, not just a penny every day. A penny the first day. The second day, you got to give me 2 pennies. The next day, you got to give me 4, but still, just pennies. And so Brock's like, "Yeah, okay." And he's like, "Do you know what you're doing?" I'm like, "Oh, yeah, I'm good. I went to teacher's college. Come on, I can build an addition." And he's like, "Well, that makes sense." So he hires me. So the first day I go, and on the first day, what's he have to pay me? Okay, he has to pay me a cent. Shh. I mean, there are, by the way. Like, there wasn't, just to be clear, there wasn't like an act of parliament and all of a sudden all the pennies in the universe ceased to exist because Justin Trudeau isn't Voldemort. They don't have the power to like cause matter to decompose. So there's still pennies, and that's what, you're just bitter because you didn't get the contract, all right, Alondra? Just because I undercut you in price and time, and now you're all angry. I'm taking my penny, which Brock is giving me. It's a 1996 one. It's very shiny. All right, next day, what's he got to pay me? 2 pennies. By the way, that's 3 cents I've made so far. All right. Next day, what's he pay me? 3 pennies. Hey. No, that's not true. Next day, what's he pay me?
4 pennies.
4. You tried to rip me off. Oh. So now I've made 7 cents total. That's pretty good. That's pretty good. Let's keep in mind that by Alondra's 3rd day, she's made like 10 grand. But that's okay. I'm catching up. Slow and steady wins the race, right, team? Yeah. All right. Next day, what do I make? By the way, whoever made that expression, just to be clear, slow and steady does not win any race. Steady, I guess. Steady is good. But, yeah. Anyway.
Just because you wait for the other person at heat stroke and then you grab the car.
Okay, so if you assume that the other person's incompetent in some way, then maybe.
It's an ace
But anyway, okay. Next day, what do I have to get paid? 8 cents. Okay, I'm catching up. So I'm up to a total of 15 now. Next day, what do I get? 16 cents. Okay. That brings me to 31. I'm getting there. After that, 32 cents. And that brings me to 65 cents. I am. Oh, that doesn't give me 65. It gives me 63, right? Yeah, that makes sense. Okay, I can add. No. Okay, next day. 64 cents. And that brings me to a total of, what, 127? Hey, I'm over $1. I've made $1. This is great. This is great. We are a third of the way there. Well, we're almost a third of the way there. So the next day, what do I get? $1.28. And that means that I am now up to $2.55. Ooh, okay. So let's be clear.
Okay, you're already overpriced. You're
One third of the way. One third of the way there. And Alondra will have made roughly $40,000, and I have made $2. $2. Oh boy. Next day, what do I make? In fact, stop talking to me. I want you to fill this all the way out. All the way out. Go ahead. Oh. Stop whining.
No.
Well, now I'm picking up speed. I'm at the end of week 2, and I've made $163.83. That's pretty good. Just to be clear, Alondra has made 67,000, but you know, I'm catching up. I'm catching up. I am totally catching up.
I feel like you gotta put this in comparison so you can say, oh, you got this, but I'm way higher.
Right?
You read more.
16 cents.
Did you add the original penny way back from day one?
Yep.
Did you add them all up?
167,000.
All the other numbers even. Every number is even but half that amount. You know what I mean? But other than that, I mean, do that. But yeah, good. Good.
No, my idea was the better deal.
It's true. I totally screwed Rocco. It felt good. Okay.
Only if he's an idiot.
Now, having said that, if I'd finished a day early, I'm screwed. But if I take a couple days extra, I'll be a millionaire, right? So what is happening here? What is happening here?
Just screwing someone over.
Yeah,
You could just display
Right?
a wall and say, I need to fix it.
You're gonna be broke for the first couple weeks.
yeah,
Daily
absolutely. What we're experiencing here is something called exponential growth. Now, looking at this, is exponential growth steady? No. No, in fact, it starts out really slow, and then it ramps up. Now, how could I have done this with an equation? We're going to start thinking about it. I want to look at another example, and I'm not going to make you do math 24 times this time, I promise. But I like this example because this is how money really does work. Now, this is at 100% interest, which you will have trouble finding 100% interest in your life, nice as that would be. But still, this is how interest works. This is why when we tell you, and probably you've heard this from teachers and parents or whoever, but if you haven't, God, you're going to hear it from me this semester, invest young. Invest young. You are better off.
They told me I couldn't.
You are better off getting money, even if it's just in a low interest like GIC or bonds early on, but starts to grow. Then when that turns into a bit more money, you can move into the mutuals market. And then when that turns into a bit more money, you can move into the stock market and start making some serious returns, but start young. Because what was my friend here? Time. What if instead of this being a 24-day project, it had been a 20-day project?
You would not
You would not have made money. All of your work is for quick.
Yeah, I'd have been
Failed.
screwed,
You would-
right? When it comes to exponential growth, That time frame is the most important thing. Sorry?
Who says the longer is being paid daily?
Yeah, that's the thing. She quoted a price for the job. I quoted a daily rate.
Who says it wasn't daily?
Well, who knows? But the point being, so when we tell you start saving money when you're young, it's not just, oh, it's to form a good habit, this or that. The way money works, you will make more money getting $20,000 on the market when you're 20 years old than if you put $150,000 on the market when you're 40 years old. Less money will make more for you in the long run. That's true. In real life, that's how the markets work. Time is your best friend. Given enough time, anyone can become a billionaire. Now, Donald Trump boasts about being a billionaire, but the truth is, if you had taken the loan that his father gave him to start his business and just invested it in an indexed fund that matched exactly the Dow Jones Industrial Average, he'd be worth $7 billion today, which, to be clear, is more than what just about anyone says he's worth, except Donald Trump. But to be clear, when he decides how much he's worth, he says that his name alone is worth $6 billion. That's true. You can look it up. Anyway.
Wait, that might be his net. Other people pay to use his name.
Yeah, no, it's true. I mean, it is his source of future revenue. There is something to that. I mean, he's not completely. I mean, he is completely out of lunch, but in that particular sense, he's not. No, he is. I mean, he's a disaster. But that's a different discussion. And to be clear, like, that's not a conservative or a liberal position to take.
But he's an idiot.
But he's also bad at everything. I mean, he's just not good at anything. And look, take it from someone who's bad at everything. Like, hey, you can still live a long, happy life, but I shouldn't be president, and nor should he.
You're really
Anyway.
good for downgrading yourself. Like, even on tests and everything, you just downgrade yourself.
Listen, nobody's a bigger fan of me than I am, but you got to be honest with yourself. Anyway.
Kind of narcissistic saying I couldn't say that's also true if I got the right answer.
Sorry?
If I clicked the right answer, I could say the mean answer. That's something.
What's that?
First test, you said I couldn't click the mean answer if I was right.
I stand by it. Okay, so I want to look at another example of exponential growth. So, what if I had a colony of 100 bacteria? All you biology lovers, all you biology students, I love biology. I miss teaching it. So if you have 100 bacteria, how do bacteria reproduce? Has anyone ever seen this? Oh, yeah, they do. But watch, it's really cool. Let's see if I can. Yeah, no, this is good. This is cross-curriculum. Yeah, we're cool.
We were in biology. We know this stuff.
No, because I was just saying.
Well, I am teaching, so I will put on the screen whatever I want. It's not a long video, but so this is a real micrograph. This is a real micrograph. Now it's sped up 5. So here we have 2 streptococci bacteria, rather, there's 2 of them. And how do bacteria reproduce?
They divide.
Sorry? They don't, actually. That's the interesting part. If I heard right, they reproduce asexually. So they just make a double copy of everything inside of themselves and then split themselves in half. Imagine if we did that. If you briefly had 4 arms and 4 legs and 4 eyes, and then all of a sudden it was just like, that'd be, anyway, that's what bacteria do. Moving on. So if you watch, every 1 bacteria becomes 2. And then every 2 becomes 4. Yeah, aren't they kind of adorable?
No, they're not.
Okay.
They just keep growing.
Yeah, so I mean, this is not a great video, but it is real footage. That's not like a computer animation or something. That's what actually happens. Oh yeah, billion. Do you know that right now inside your body, there's approximately 2 pounds of bacteria? Think about that for a minute. On the order of about 2 pounds of bacteria. Yeah. Chris- Oh yeah, they're almost exclusively good bacteria. You couldn't digest your food without them. We live in a symbiotic relationship with them. Right? So anyway, that's what we're talking about here. Exponential growth. So we start with, how many did I say? 100 bacteria.
How can it be day 0?
Day 0.
It's not even
There
a
was
day.
always a day 1 or prior.
No, in math, and you'll see why. In math and science, we don't like to call the beginning day 1. We like to call the beginning day 0, and we'll talk about why. It's actually the direct result of
So day
the,
0 is representation of nothing.
it's the direct result of the math we're going to learn today and on Monday. Why we use day 0 for these things. By the way, we do this all the time. What do they call the first person to contract the disease? Patient 0. What do you call the place where an explosion takes place?
Ground 0.
Ground 0. Yeah. So in math and statistics and science, the locus at which something happens, whether in time or space, we refer to that as point 0, whether point in time or point in space, and we'll talk about why. So go ahead and fill this chart out. Yeah.
It's been like 24 hours and by day 1, something else has happened.
That's what, yeah, that's definitely on the right track, like 100%. And then there's also a reason specifically related to the function, the way the function works, and we'll talk about that as well. But in terms of common sense, that's a great explanation. And common sense counts for something too, you know, I think. Maybe.
Wait.
Yeah.
You're right.
Friday. It's one of those weekdays. Tomorrow?
Where are they?
It's April 12th. It's not Saturday.
Could you imagine?
The Sunday announcement, Saturday has been removed.
Saturday is canceled.
Yeah, because the government.
Oh, but Saturday, I'm so scared. I start my first job tomorrow, and I think I'm gonna walk in and like, April Fools, you didn't actually get the job.
Oh, that'd be awesome.
That would be awful.
That would be fun.
I used to have a manager. I worked at a restaurant. I was just a waiter. I was maybe 18. And this place was open till like 3 a.m. But after, say, midnight, it was hell. It was just drunks, and you just wanted to go home. And the money-making portion of the night was done. And then if you stayed to the end, it was just like clean up and dealing with miserable people. So you always wanted to be cut, right? You always hoped that there'd always be like 2 people who stayed and 6 people who get sent home. And he used to work with this guy, Jay, and he obviously didn't like me. So he'd get off and go, Joe, you're cut, you can go home. That's what I'd be saying if I hadn't said that. I'd go, didn't feel very good.
Just because they like you, so that's
That must be it, yeah.
like that's why I have.
They pick on me 'cause they like me. Yes.
Have a tear.
Okay, show me. I do want to see it. Don't. I get. As you know, I get distracted. Okay, so obviously on day 1, as day goes forward, what will we have? 200. And on day 2? And after 3 days, 800. After 4 days, 1600. Now, let's note, traditionally, do you remember, and we probably haven't done this in a long time, but way back in grade 9 and grade 10, if you wanted to check to see if something was linear or exponential, you would check the
Graph.
graph. If you didn't have a graph, remember checking first differences, second differences? Does that ring a bell?
It rings a bell, doesn't mean anything. It doesn't mean
I don't want you to write what I'm about to write, so just look. If I took the differences here, what's the difference between 100 and 200?
100,
Yeah. And the difference between 200 and 400?
200,
And the difference between 400 and 800?
400.
Yeah. And the difference between 800 and 1600? We're going to see 100 and then 200 and then 400. We're just going to see the same pattern over and over and over again. Does that make sense? So checking first differences for this doesn't tell you anything. Well, I guess it tells you something. You'll see the same pattern. But that's because when we do this kind of growth, we're not adding and subtracting. What are we doing? Yeah, we're multiplying. So we don't take first differences here. We take what we call the first quotient. Ooh, with the more common U before O spelling. Which is just to say, what is 200 divided by 100? What's 200 divided by 100?
2.
2. What's 400 divided by 200? 2. What's, yeah, very good. I think we got it. Okay, and this tells you the growth rate. So you can look at a table of values if something is exponential growth, and you can actually see what the growth rate is. You can see what the growth rate is. And again, if we graphed this, we would say, well, how high do I have to go? I have to get up to 1,600. 2, 400, 600, 800, 1,200, 1,600. Oh, 200. That's what I went by, right? Oh, that was poorly chosen. Okay. Okay. 1 day, 2 days, 3 days, 4 days, 5 days, 6 days. Okay. So on day 0, when no days have passed, how many bacteria do we have? Yeah, we have about 100. That's going to look roughly like this. After 1 day, how much do we have? Anybody? After 1 day, what's the population? 200. Good. Which looks roughly like that. After 2 days? Good. Roughly like that. After 3 days? 800. After 4 days? Good. And I'm not even going to, I know it wasn't in the table, but what would it be after 5 days? What's twice 16? Yeah, so that's a whole other square above here like that. Now, here's my question. Mathematically, what are we doing with this? Well, we're taking the amount we started with. How much is that? Yeah, so the number is equal to the 100 we started with, and then what are we doing with it? Yeah, we're doubling it. And how many times do we do that? Yeah, how many days? And this isn't any kind of formula, I mean, I just made it up myself. But we can figure out how many bacteria there are. By taking the 100 we started with and doubling it, and then the exponent will just tell us how many times we have to double it, which of course, in this case, is just how many days. So could you use that to tell me how many bacteria there will be after a week? Sure, how would we do that?
100 times n to the exponent 7.
So we'd do n equals 100 times 2 to the exponent. Cool, do that. What do we get? What do we get? Yeah, to the exponent 7. It's going to be fairly big. 2 to the exponent 7 is what? 256? Is that true?
Well, 12,800.
12,800?
I don't like my numbers.
Okay, what about after 3 weeks? What would I have to do? N equals, Yeah, 100 times 2 to the exponent 21. And this is going to be big.
Not.
It's 2.0975
10 to the what? What's the exponent? 2.09 times 10.
No,
Error.
2.29715.
Yeah, I don't want all the decimals, just after the E. 48? Okay, so that is in scientific notation, 2.09 times 10 to the 48. If you're wondering, that's more atoms than there are in the universe. So that's not going to happen. Yeah, that's a big number. Is it really that big that quick? That seems too big.
2 million.
Yeah, did you do that? What's the E on that again? That seems too big. My instinct is that is really
I
big.
got 2 million.
They did the exponent 10 to the 21 instead of 2 to the 20.
Yep, that makes
I
sense.
got 209,715,200.
Yeah, I like that. That makes more sense to me for this one. Now, it wouldn't take long to get there. That's the crazy thing, but this makes more sense in the short term.
I have 209,715, and it says a 2 there. There you go.
Let me see.
There was just no 0 at the end.
Yeah, but you did 200 to the exponent 21, which you can't do. That means 200 times 221, which is a lot bigger. So you have to do 100 times 2 to the exponent 21. Because remember exponent laws. I can't simplify this unless they're the same base. And these are not the same base. So you have to follow Bedmaster. You have to do exponents first, then multiplication.
Okay, now I don't have that.
Nice. Now you get this number? Great. Does that make sense? Again, we will talk about how to make these into functions on Monday. I just want to look at one more very quick example, and I'm going to leave you alone. Yeah, that's a quick one. What's the opposite of getting bigger as you go? Getting smaller as you go. So if by multiplying to get bigger, we call that exponential growth. Instead of that, if we multiply by a fraction or if we divide over and over again, that's going to be exponential decay. That's where we get smaller. And there's a lot of things in life that work this way. A lot of things in life that work this way. This, by the way, is how being in debt works. Really and truly. So don't do it. Actually, I guess there was exponential growth is also how being in debt works. They both can go that way. Actually, this isn't how being in debt works. I lied about that. But this is what buying a car is like. You buy that car, it's worth $20,000 until you set foot in it, and that's worth like $16,000. And the next year, it's worth way less, and way less, and way less. And before you know it, it's worth nothing. You can't sell it. You just take it to a scrapyard, and they take it and turn it into a cube. So anyway, it's also how bouncing a ball works. Right? We know this. If you drop a basketball, it bounces, but it doesn't keep bouncing back up to the same height, does it? You okay? Unless it were flubber, which it isn't. A non-flubber basketball is dropped from 40 feet. In this particular case, I'm going to say every bounce it loses half its height. So before it bounces, what's its height? 40 feet. After the first bounce, it'll come up to 20. After that, it'll come up to then 2.5. And if you want to, 5, 1.25, you could keep going forever and ever. So now let's graph that. You take a minute and you graph it. Am I ruining your day? Oh, I'm sorry to hear that. Yeah, okay. 5, 10.
Actually, very helpful. I was never really good at writing myself was very agnostic to it.
Do you have them going down?
No,
Can I see before you erase?
because I put the 0 over here, but because
Well, you can. It would be probably quicker just to erase these.
oh yeah. See if I
That's what I do.
I'll do the wrong way.
Is that the other bracelets? WWJOD. I like that. That plays right into my messianic complex. I don't know.
Hey. Why?
Or do I?
0.
Sir, why are you always so optimistic? It's kind of scary.
Yeah, that's why I called them a cycle on like the third day.
Because life's a good place. Listen. Do you understand?
So you're lecturing me, you're so happy.
You know what Warren Buffett calls it? Winning the ovarian lottery. So,
Okay,
Right.
so you're just saying that your
God.
chances of being alive.
not just your chance of being alive. I mean, first of all, your chances of being alive are infinitesimally small. Infinitesimally small. On the other hand, your chances of being alive are also 100% because it happened. Right? So depending on how you like to think about probability, the odds of you being born are either one in hundreds of billions and billions and billions, or 1.000 because it happened. So that's done. That's good. But you didn't just get born. You got born in Canada, and that, my friend, is it's 30 million out of 38 million out of what, 8.2 billion? So pretty low. Population of Canada, population of the world.
Population of the world is less than like 6.8 billion.
No, it's 8 something, isn't it? I could be wrong about this. I'm not a population scientist, but now I'm curious. Oh, well,
7 billion.
7 billion. Okay, sorry about that. So there you go. So about 38 million out of 7 billion. Those are low odds, man. But even say like any, Western European country where we're all rich, even if we're not rich.
0.5%.
There you go. 0.5% being born in this country, right? Just crazy. And then you and I, born male. Let's talk about those advantages.
And
Tons of them. And white and male.
So
It's right. Like, listen,
okay, totally.
I got news for you. It's easier, It just is. right?
You don't say that out loud.
No, but it is. It is. It's like you're not supposed to say it. It's like I have friends who teach elementary school, and they're always like teaching so hard, and I'm like, yeah, but on the inside I'm thinking, you're kind of teaching so hard. I teach high school, 3 classes a day, 75-minute break in the middle of my day, and lunch. But like you don't
Having
say
a
that
low
to them.
Percentage doesn't necessarily mean your life is good. It's a low percentage.
No. I get that. I get it. But I'm just saying, like, we got it good. Like you're in a school right now, and who's paying for it? Other people. That's amazing. It's amazing. Just other people. You'll never meet them. You'll never have to say thank you. But like just today's tax filing day, right? Your taxes are due tomorrow. But you don't have to pay taxes, even if you have a job, because the government doesn't make you because you're young and you don't make much money. So like here you are in school, and other people's taxes are paying for you to be here. I'm paying a little bit of my own wage right now, which is bizarre, but there you go. Life's good. Life is good. And I teach math. Sorry?
Is it thanks for sending you to school?
See? That's
Now,
right.
That's something I should have done a video.
And let's think about it.
Teacher Patriot of Canada.
Yeah, and let's think about this for a minute. It's not cheap. You know what the DSPN pays for every one of you every year?
Well,
No.
not every year.
Every year, every one of you, roughly $7,600. $7,600 per student per day. Or per year, rather. Per student per year. So if you think about that, 192 school days, that means you are costing Jimmy taxpayer $39.58 today. Now you got 4 classes. That means this class just today, $10 for each of you. How many of you are in here? That means $108.
So they have to divide that by the amount of
Just for this
people in
class.
Canada for taxes.
Right? Yeah, well, people
And then
pay
it's
taxes.
how
Lots of
much
people don't.
was
Lots of people are in the
taxed.
stages in their life where they don't have to pay. But I mean, it's largely property taxes. Anyway, all of which is to say, we got it good. Now, let's talk about this. The height of the ball drops. Now here, we had to take 100 and we had to double it. Down here, what are we starting with? 40. So let's call this height. We're starting with 40, but we're not doubling it now. What are we doing? Yeah, we're cutting it in half. And then, how many times are we doing that? Well, I'm just going to use n. I like n. It's a good letter.
If you divide it by 2 instead.
You totally could. You could 100% divide it by 2 to the exponent n, and that is mathematically identical. So yeah, if you prefer h equals 40 divided by 2 to the exponent n, sure, nothing wrong with that. If you like 40 over 2 to the exponent n, hey, nothing wrong with that. So I have to put menus in restaurants. People like different things.
No, you have
Of course it makes sense.
You can't do it.
One thing you'll discover about me, I make a lot of sense. Not at first. At first you're like, that guy doesn't know anything, but then slowly over time, you're like, wait a minute.
Well, you make a lot of sense for a teacher in Canada. Like, my God.
Yeah, and dollars. So here we go. Now, last thing I want to talk about today. You guys ever heard of Zeno's paradox?
Zen.
Zen, like, how you feel in math every day? Oh, that gets a laugh. That gets a laugh. What's that? Oh, that's yours. Thanks.
Did you just ask us that rhetorically? Because, like, you knew we were all going to say no.
No, I don't. Like in science, we talk about a lot. You guys have taken science classes. Listen, let me tell you something. I know that's different.
Oh my
Come on,
god.
it's rated like
Yeah,
637 on all
So
of them.
Zeno's paradox. Zeno's paradox. Maybe Zeno, not sure how you pronounce it. I've only ever seen it in writing. But here's an interesting question. According to this equation, does the ball ever stop bouncing?
Or the equation that was.
Well, 40 times a half to the exponent n.
Smaller and smaller and smaller.
Yeah, smaller and smaller and smaller and smaller.
It will
Right?
eventually stop.
Well, we know in the real world it will. According to the equation, will it? No, it'll just bounce by less and less and less and less and less. But exactly. And what does it mean for something made of atoms to be bouncing by less than the distance atoms normally move on their own anyway, right? I mean, we understand now with modern science that those practical considerations here. So I mention that because we have to be mindful, and this is what I want to talk about. This is a science lesson that I'm about to spout off to you much more than the math one. But we understand that when we describe the physical universe with math, it works really well on big scales. And when we get to small scales, what we call the quantum scale, the things the size of atoms, our simple Newtonian ways of describing the world, this math that does a great job and describes things really well on the big scale, breaks down. It fails. It doesn't work.
It's multiple choice.
So remember at the beginning of the year where it said math kind of sucks? And breaks down and fails?
I remember bursting into tears on the inside. Why did you say that? That's what I was
Mr. Ramos, I just tell him that night. It's like,
So anyway, Zeno's paradox was, it's worth a read actually. I'm not going to give it to you. I encourage you to commit it to your reading. It's kind of Aesopian fable in its own. It's about a tortoise challenging Achilles to a foot race and outsmarting him by convincing Achilles that he cannot win. So Achilles concedes the race and lets the tortoise win because the tortoise outsmarts him with math. Now, as it turns out, he didn't outsmart him with math because what he was saying was wrong. But the point was Achilles believed him, so it worked. So Zeno's paradox, I commit it to your reading. It's worth a read. I'm not giving you homework for the weekend. I just wanted to introduce I wanted to introduce this. I wanted to introduce this to you conceptually. We're going to formalize it on Monday. Monday, we're going to turn these into functions. Okay.
Which one of them?
Both of them. They're the same kind of function, actually.
I feel